Hi, welcome to my video on circles, and this video is on inscribed and central angles and arcs number 3. I have a circle drawn with center O, and I have a central angle TOP because it's made up of two radii and the vertex is at the center. I also have an inscribed angle TKP made up of two chords with a common vertex of K of the chords, and K lies on the circle. So let's measure the angle TOP with a protractor. So we place the protractor on the angle with this point right here at the vertex of the angle, and this angle comes out to be, and as you can see running up here, it's 80 degrees. So I have an 80-degree angle right here. So angle TOP is 80 degrees, and that's the central angle. Now we have an inscribed angle cutting off the same arc TP. Notice the central angle is TOP, so the arc that it cuts off is TP. This is an inscribed angle TKP, and this angle is also cutting off the arc TP. So let's measure the angle of at K. And the angle at K, placed along, here's the protractor, and this angle comes out to be, and you can see it's, I gotta make sure I put that right at, so here's the point on this is the semicircle, so this point is right at the vertex, and that comes right up to there at 40 degrees. So we have this angle measured at 40, this angle is measured at 80. So the angle TKP is in relation to angle TOP. The measure of TKP is half the measure of TOP. If an inscribed angle and the central angle intercept the same arc, then the measure of the inscribed angle is half the measure of the central angle. So that's a property that we have to keep in mind when we're looking at circles. The central angle is twice the measure of the inscribed angle when they intercept the same arc, or the inscribed angle is half the central. So let's do some extra examples. We have a circle with center O right here. Express y as a function of x. Y is cutting off this arc right here. Let's say this arc is AB. So the inscribed angle is cutting off the arc AB. This is the central angle at O, cutting off or intercepting the arc AB. Both of them are intercepting the same arc. So that means the inscribed angle, which is y, is a half of the central angle x. So y is a function of x. And we have another problem, and we have O again as the center, and we have the arc PM is 100, the arc MF is 120, so all the way around the circle is 360 degrees. So we have 100, we have 120, so that's 220 total, and so 360 is all the way around minus the 220, it gives us 140. So this arc PF is 140. So the arc PF is, notice is marked with 2 letters, so it's a minor arc. So it's 140 less than 180. And so angle POF is a central angle labeled by B. So angle B is 140 degrees because the central angle and the intercepted arc are the same measure. And we have a triangle OPF, and OP is equal to OF because the radii of a circle. All radii of a circle are equal. That means if I have two angles equal, I have two sides equal. So that means if I have two sides equal, I have two angles equal. So x is equal to y. So we have 180 degrees in the triangle. We have angle B is 140. So that leaves 40 left over for the other two angles. So if the other two angles are equal, then 40 divided by 2 gives me 20. So x is 20 degrees and y is 20 degrees. And we have that angle A is half the central angle. So the central angle is 140, so A is 70. Because this is an inscribed angle made of two chords with a common vertex. So this angle, inscribed angle right here, is intercepting this arc. The central angle, POF, is also intercepting this arc. So the inscribed angle is half the central, which makes it 70. So let's continue with some more problems. Again, the more problems we do, hopefully the more we'll understand. Here I have a diagram drawn, and the arc BC, the arc BC here, I have labeled as X. The arc, the angle, I said arc, the angle BOC, the angle BOC, I've labeled as Y, and the angle BAC I labeled as D. So BAC is labeled as D. The reason I did that with these letters, so we wouldn't have so much writing to do. Using X, Y, and D, prove the measure of the inscribed angle is half the measure of the intercepted arc. So we're going to prove that the inscribed angle, which is D, is going to be half this intercepted arc X. So starting out, we have Y is equal to X. And that's number one. So why is Y equal to X? Because the central angle is equal to the intercepted arc. Now, to do the math, we need a half. So a half of Y equals a half of X. So that's what we call the multiplication property of equality. I need a half. I know I need to prove. I have to prove. I'm given this information, so I have to prove that D is equal to a half X. So the inscribed angle D is going to be a half of the intercepted arc X. So I need a half in it. So if I multiply this equation in number 1 by a half, I get a half Y equals a half X. So based on that, I know that D is a half of Y. D is a half of Y because the inscribed angle equals a half of the central angle. And as a result, notice here we got D is equal to half Y is equal to half X, so that means D is equal to a half X. So the half Y is right here, half Y is right here, so that's called the transitive. That's called the transitive property of equality. Again, repeat, half Y is here, half Y is here, so half Y is equal to half X, half Y is equal to D, so D is equal to half X. So that's the proof for proving that the inscribed angle is half the intercepted arc, because we need to use that in our videos and our problems that we're going to do. So let's do another example. 0 is the central, 0 is the center of this circle. JN is a chord, so JN is a chord. And if JN is a chord, that means that JN is a diameter. I didn't say it was a diameter, I just said it was a chord. But a chord, JN, that passed through the center of the circle is a diameter. This being a diameter means that this arc up here is 180 degrees. This arc here is 180 degrees. So JN RN is 180. This central angle is 180 because that's a straight angle. So the arc, we'll come across that in the next video. So the arc is going to be half the intercepted. This central angle here is equal to the intercepted arc. So this intercepted arc is 180. This central angle is 180. This arc is 180 because the central angle is 180. Now, we're told that the measure of JR, the arc JR is 180. So this arc here is 138 degrees. 138 degrees for this arc here. So all halfway is 180 minus 130. So we have 42 degrees. So this arc right here is 42 degrees. Oop, we got degree in there, so we'll put another one in. So this is 42. And the angle, excuse me, the angle NJR is the inscribed angle, and is cutting off the arc NR. So that means that this inscribed angle is half the measure of the intercepted arc. So that's 21 degrees. So this angle is 21 because it's half the intercepted arc. Again, 180 in the semicircle. This is 138. That's 42. And this is an inscribed angle, half the arc. Intercepted arc. Okay, again, some more problems. The more we do, the better we should understand, hopefully. O is the center of the circle here. And we have the measure of the angle AOB 50 degrees. The measure of AOB is the angle, and that's 50. And it says that the arc HT, is equal to, in measure of the arc AB. So this arc right here is the same measure as this one. So what is the measure of AB? Well, the angle AOB is 50. So the measure of the intercepted arc is 50 because they're equal. Since these two arcs are equal, this arc is equal to 50. So the arc, we have AOB is 50. We have the arc HT is 50 because they're equal to each other. So what is the measure of the angle HWT? HWT is an inscribed angle. And the inscribed angle is half the measure of the intercepted arc. Since HT is 50, this angle must be 25. Just another little problem to do. Now I have another interesting problem based on the intercepted arc is, or the inscribed angle is half the intercepted arc. Now what we have is a circle, and we have this arc is 6x, this arc is 10x, and this arc is 8x. So if you take 6x, add 10x, and add 8x, all the way around this circle is 360 degrees. So that means that if you add that up, you get 24x is 360. That means that if you divide by 24, you get x is 15 degrees. And if x is 15 degrees, so we have what x is, we need to find the measure of angle PFT. So the angle PFT is an inscribed angle. So this angle is going to be half of this arc. So the angle, the arc, the measure of the arc PT, the measure of the arc PT is 10x. And that means that x is 15, so 10 times 15 is 150. So the measure of the angle TF or PFT is half of the arc PT, and so the arc PT is 150 degrees. So the angle right here is 75 degrees. And this arc here is 150. So this is the arc, 150. This is the inscribed angle cutting off. So notice this inscribed angle PFT, this inscribed angle is cutting off this arc. And so to measure up the arc is 150, the inscribed angle is half of it. So that's the review of two concepts here. And the central angle is a half the measure of the inscribed angle is half the measure of the central. And since the central angle is equal to the intercepted arc, that means the inscribed angle is half the measure of the intercepted arc. And again, if you like my video, click on the like button, click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.